Welcome back, everyone. Next up, we have Ideal Power. It trades on the NASDAQ under the symbol IPWR and is pioneering the development of its broadly patented bidirectional semiconductor power switch, creating highly efficient and eco-friendly energy control solutions for electric vehicle charging, renewable energy, energy storage, UPS data center, solid state circuit breaker, and other industrial and military applications. The company is focused on its patented bidirectional bipolar junction transistor, B-TRAN, semiconductor technology. B-TRAN is a unique double-sided bidirectional AC switch able to deliver substantial performance improvements over today's conventional power semiconductors. Please welcome its president and CEO, Dan Brdar, and CFO, Tim Burns. Welcome, gentlemen. Excited to hear about this fascinating industry you guys are in.
Good morning, and thank you very much for having us. We're looking forward to telling everybody about our technology and where it applies.
Wonderful. Take it away.
Okay, our technology is what we call B-TRAN. It's a disruptive semiconductor power switch. It has three compelling advantages. The first is it is inherently bidirectional. So if you think about utilizing batteries today, you have the charge and discharge of the battery. So in one device, the B-TRAN can handle that bidirectional power flow. It's also very low loss. This results in energy savings for the end user in their application. And then something like an electric vehicle would result in improved range for the EV. Also, because of those lower losses, less heat needs to be dissipated. So that can result in smaller, lower cost OEM product designs. The technology is a scalable solution across several power levels and also some large and growing markets. Things like electric vehicles and renewables that have very significant macro trends behind them, as well as energy storage, solid-state circuit breakers, and various other industrial and military applications. We introduced our first commercial product here last month in January. That's the SymCool Power Module, and we're expecting first commercial sales of that product later here in 2023. Our business model is asset-light, fabless business model. We do not own a semiconductor fab, nor do we intend to own a fab. We're really relying on the existing silicon processing infrastructure that's out there today and really working with third parties for things like the wafer fabrication itself, for the packaging of the device, for assistance with design work, et cetera. So for us, very, very low capital intensive business with really minimal CapEx other than just test equipment for our lab here in Austin. We are engaged with multiple target customers in all of our key market segments. So again, things like EV, renewables, energy storage, and solid state circuit breakers. And we have a really broad patent estate around the technology with 72 issued and 24 pending patents related to B-TRAN. In terms of commercial agreements and collaborations, we recently, late last year, entered into a development agreement for a custom B-TRAN power module with a top 10 global automaker. So this is a program, we're in phase one of that program right now. We expect here over the next few months to complete phase one and move into phase two of that program. But that is to basically have multiple B-TRAN dies within a custom B-TRAN module for use in that global automaker's EV platform. And the goal of that program is to have production-ready custom B-TRAN modules for 2025. We've also announced several collaborations for the testing and evaluation of B-TRAN, where we'll be providing customer kits to those customers. They will actually test the device and actually evaluate it for use in their applications. And then they'll provide us feedback that we can incorporate into our product planning process. We've already announced a different top 10 global automaker, top 10 global solar company, power management market leader, a leading commercial EV manufacturer, and several other companies, including EV charging companies as well. We also have a program with the Navy for a solid-state circuit breaker, and we've completed most of the major milestones under that program. We've delivered 2 deliveries, actually, of devices to DTI, our partner under that program, and that will result in the demonstration of the B-TRAN technology in a 12 kilovolt solid state circuit breaker to sites selected by the U.S. Navy. In terms of significant advancements and milestones, as I had mentioned, we introduced our first commercial product in January. That's the SymCool power module. So it's a multi-die B-TRAN power module. We expect first commercial sales again later this year. And then looking forward, we expect to complete phase 1 of that multi-year development program with the top 10 automaker here in the second quarter of this year and move into phase 2 of that program. We expect to complete our first engineering run with a high volume production fab in the second quarter of this year. To date, we've been working mainly with 2 development fabs here in the US, Teledyne and another fab. And this will really allow us to get ready to scale in terms of the commercialization of the technology, moving to a high volume fab that just has stronger process control and can handle much higher volume and larger wafers than a development fab. We'll also continue to deliver packaged B-TRANs to diversified technologies under the NAVSEA program that I mentioned throughout the first half of 2023. We will introduce our second commercial product, which really leverages the SymCool power module, and we'll be adding a driver to that to control the device to make it an intelligent power module. Timing of that is expected in Q3 of 2023. And unlike the SymCool power module, which is really targeting the solid-state circuit breaker market, this second product will really target things like renewables, particularly when paired with energy storage and other industrial applications where the OEMs want a module that includes that driver. Unlike in the solid-state circuit breaker application, where generally the driver is done at the system level, not on the individual module. And then from a cash perspective, we have cash runway potential through at least Q4 2024 with no debt. So we're well capitalized as we're commercializing the technology here. So what is B-TRAN? You can see a picture of a B-TRAN on the right side of the slide. It's actually about the size of a dime. And if you actually flip that die over, it will look the exact same and is perfectly aligned on the other side of the die, which really makes it unique. So typically, conventional semiconductor devices are just processed on one side of the die. So what's unique is it is a new disruptive design, so it's an architecture. So just like if IGBT, which is a commonly used power semiconductor device, is an architecture, the B-TRAN is an architecture. And it's also fabricated, as I had mentioned, on both sides of the wafer, which is something we really spent the last couple years working with those development fabs on how do you make a double-sided die or a double-sided wafer at a fab without significant capital expenditures. So we've actually, through that process, developed process flows where there's no additional CapEx for a semiconductor fab to make a double-sided B-TRAN wafer relative to what they already have in their fab for silicon processing. So that's probably something that was, I would say, probably the longest development activity, was really trying to make sure we could easily transfer and manufacture the technology to a new fab without any CapEx requirements. As I had mentioned earlier, B-TRAN architecture does have the 3 compelling advantages. So the bidirectional switching, the lower losses, particularly lower conduction losses, which really enables things like solid-state circuit breakers where you need highly efficient and very low conduction loss devices to make solid-state circuit breakers work. And again, it can result in smaller, lower-cost product designs for the OEM. So we've manufactured the devices, we've tested the devices. Those results were consistent with previous simulations. So now it's really moving on to just truly commercializing the technology. If you were to make a bidirectional switch with conventional devices, you typically need 4 devices. So you pair 2 IGBTs with 2 blocking diodes that just prevent energy from flowing back in the wrong direction. And those 4 devices would make up a bidirectional switch. The B-TRAN is a bidirectional switch in a single device. So a significant reduction in part count. And conduction losses in bidirectional applications for the B-TRAN are more than 4 times better than a bidirectional circuit with an IGBT and a blocking diode. So significant performance improvement relative to conventional technologies that are used today. The IGBT market, which is really the power semiconductor market, interestingly enough, the 2 largest segments of that market are already electric vehicles and renewables, 2 of our target markets. Other significant markets, UPS systems for data centers and motor drives. That market's expected to reach $11 billion by 2026 and is growing at a double-digit rate. So some of the key addressable market segments for us, the electric vehicle market's already a $1.5 billion IGBT market, growing at 15+% per year. And there's power switches throughout an electric vehicle. For us, we're power semiconductor devices, so places like the traction motor inverter, the onboard battery charger, are logical places to utilize a power semiconductor like an IGBT or a B-TRAN. Other key addressable market segments, renewable energy, particularly when paired with energy storage, where you take advantage of the bidirectionality of the B-TRAN technology, is a $1.1 million market segment, also growing at over 10% per year. And then the data center market's about a $0.5 billion market, growing at about 6% per year. But that's somewhere we've done some work to see what the potential impact would be of utilizing B-TRANs in UPS systems for data centers rather than conventional technologies. And we estimate it would save the average data center over $2 million a year in terms of electricity savings if the UPS systems contain B-TRANs rather than conventional power switches. So pretty significant economic impact for a data center. B-TRAN's impact in electric vehicles, I had mentioned the traction inverter and onboard chargers, two logical places to utilize the B-TRAN in EVs. Another place, power DC to DC converter within the drivetrain, and also circuit protection as well. Interestingly enough, after the batteries, power semiconductor switches are the second largest cost component of EVs today. So pretty significant, 8 to 10% of the total EV production cost is actually semiconductor devices. We did some work, actually leveraging some work previously done by Toyota to see what the potential impact would be of the improvement in efficiency utilizing B-TRANs in an electric vehicle compared to conventional technologies. From that analysis, we estimate that it would be a 7 to 10% range improvement utilizing the B-TRAN compared to conventional switches. So it's range anxiety being one of the major issues towards mass adoption of electric vehicles. Improving range by 7 to 10% is pretty significant. I mentioned earlier the Navy program. We had partnered with a company called Diversified Technologies, a private company out of the Northeast, and submitted a joint proposal to the Navy for a B-TRAN enabled solid state circuit breaker. So typically, most circuit breakers are electromechanical, and that's because conventional power semiconductor devices typically have too high conduction losses. So B-TRAN, with its very low conduction losses, is really an enabling technology for solid state circuit breakers, which operate orders of magnitude faster than electromechanical breakers. So we submitted a proposal. It was approved and funded under the Department of Defense's Rapid Innovation Fund, which is designed to accelerate the commercialization of high-value, high-impact technologies. This is something we've been working on over the last couple years. As I had mentioned, we have 2 deliveries so far to DTI of packaged B-TRAN devices. We'll be completing some more deliveries here in the coming months. And as I had mentioned, those will be incorporated into a demonstration of a 12 kilovolt DC solid state circuit breaker at a site selected by the Navy. Our patent portfolio, we have 72 issued and 24 pending patents. Outside of the US, we have patent coverage in places like China, Japan, South Korea, Europe, and India. We also have 24 pending patents, and those patents cover not just the device architecture itself, but control of the device. We do have a limited number of double-sided device manufacturing patents and some application-specific patents as well. But one thing we do is we treat the process flow at the fab as a trade secret. So even if someone had full access to all of our patents, they still wouldn't know the learnings that we've had over the last 2 or 3 years in how do you make a double-sided device in a standard silicon fab. You can see here some of our recent news, typically commercial announcements around our test and evaluation program, the development agreement with a global top 10 automaker, our first commercial product introduction here very recently. And then from a balance sheet perspective, we have about 5.9 million shares outstanding, about 7.6 million shares outstanding on a fully diluted basis. As of last reporting, at September 30th, our cash balance was 18.5 million. So for some perspective, for the full year 2022, our cash burn will be just under $7 million. So we have at least a couple years of cash on our balance sheet. and no debt. So that's a brief overview of who we are and what the B-TRAN technology is. And Anna, we'd be happy to open it up for questions.
Great job, gentlemen. Okay, let's get into these questions. Sorry, okay, so let's talk a little bit about some milestones. Can you give us some confidence in some upcoming milestones for 2023?
Yeah, and I'll actually go back to a slide that summarizes that at some level. But for 2023, it's really all about commercialization. So it's getting through the first phase and into the second phase of the multi-year development program. It's getting ready with a high volume production fab qualified and completing that first engineering run here in the second quarter. It's making those deliveries under the DTI program to support that 12 kilovolt solid state circuit breaker demonstration. And we'll be making those deliveries here in the first half of this year. It's introducing our second commercial product, which will be an intelligent power module. So similar to the SymCool power module, but with a driver added to that module. And then also it's initial sales of both the SymCool power module and potentially the intelligent power module at the end of the year. So I would say those are probably really the things to look for. We'll also be signing additional test and evaluation agreements with customers in our target markets as well, and we'll announce those as those agreements are signed.
Thank you for that. Rick Dunn wants to know if you have any applications on EVs currently, or are you aggressively going after EVs?
We're aggressively going after EVs. And what's interesting is that the automakers that are out there, they're all looking for new technology. They're looking for new platforms. So our timing of bringing our product to market, we think is really well aligned with what the EV makers are trying to do. And particularly since we can impact the performance of the electric vehicle by giving it longer range and do it using conventional silicon, which also helps from the cost standpoint of electric vehicles, we're getting a good reception with the automakers that we're talking to.
Donald W. wants to know how much was invested in this core technology?
So over the last several years, it's $30+ million on the development of the technology. So pretty significant investment. And some of that was funded through government grants, and a lot of it was funded through our shareholders.
And Jim J. wants to know, what is your current cash position, and will you need to go to the markets to raise any cash moving forward?
Not in the near term. So we'll end the year at over $16 million in cash and end the year with a run rate cash burn on an annual basis of just under $7 million. So we're well capitalized for at least the next couple of years and don't have any immediate plans on raising capital.
Sarah S. wants you to break down the B-TRAN model. Is it the revenue model for B-TRAN? Is it a one-time sale? Is there anything recurring for customers besides additional orders? And do you have an estimated percentage for margins?
Yeah, for us, it is an initial sale of a product. There's not an ongoing sale from that, but our model really is to start with product sales. But when you think about customers that can drive large volume, folks like the automakers, they're ultimately going to want a second source of supply. So our objective is, once we've got product out there and it's designed into OEM products by solar providers, by automobile manufacturers, is to license that technology to others that have fab capability. It would be a second source of supply, and bigger companies that would sort of take the supply chain pressure off of us trying to do it ourselves, and also allow those other companies that we're licensing the technology to the ability to leverage the investment they've already made in silicon processing and also in the front end of their business for sales and service support. So our view is we'll start with product sales, transition really to a licensing model to really supplement what we're doing. And as a result, our expectation is that we get into volume, the product sales are going to have gross margins in the 40 to 50% range. And then, of course, licensing is basically 100% gross margin.
Marshall Adler asks, what's the current technology that B-TRAN is replacing? Is there a major semiconductor company producing it?
Yeah, the technology that's out there today that we're competing with is really in the high power type devices, which are served today by IGBTs. IGBTs have been around for decades. They have gotten better, but they have kind of reached a limit in terms of what they can do from a performance standpoint. So for us to be able to bring out a technology that doesn't require exotic materials, but can deliver substantially lower losses is really what's making our technology so attractive to end customers that are looking to improve the efficiency of their power generation or the range of their vehicles.
We have a few questions from Richard Martin. One, what are your material requirements and availability without compromising your science?
Yeah, we're using basic silicon wafers. We will transition to silicon carbide over time as silicon carbide wafers become lower cost and better quality. But we don't have any issues with what we're doing from a material standpoint, because a lot of our development work has really focused on how do we leverage the materials and the processing infrastructure that's already been built for an enormous silicon-based semiconductor industry.
And can you get your materials easily? Do you use any special chips by overseas manufacturers?
No, we've been able to get the wafers that we need. They're pretty readily available. We don't use anything specialized that needs to come from overseas. And we really don't have any exposure to any of the issues that are potential supply chain disruptions from Asia.
And does the DOE or EPA recognize your fabrication process as carbon neutral, or your product's been awarded any energy savings or tax credits?
Not yet. I think it's a little early for that. As we get further into commercialization, we'll look to see whether it makes sense to try and pursue some of those recognition for some of those activities.
David Schneider wants you to confirm that who is the commercial EV manufacturer?
We have not been able to name them at this point in time. We have a non-disclosure agreement with them. As you can imagine, most of the automobile manufacturers really don't want their competition knowing what they're doing in terms of where they're going with their platforms. Our hope is that as we get further along, particularly with the custom module development work we're doing with a top 10 automaker, that we'll be able to name them. But at this point, they haven't let us do that.
Yeah, and just to clarify a little bit, so we do have one top 10 global automaker that's interested in our technology for EVs, which we're doing the development program with. There's a second top 10 global automaker looking at our technologies for EVs in our test and evaluation program. And then there's also a third, a commercial, so rather than passenger vehicles, commercial vehicle EV manufacturer that's also in our test and evaluation program. So in total, there's 3 EV manufacturers that we're already working with and collaborating with.
Thank you for clarifying. Randy Svedbeck asks, how much inventory will you need as you commercialize B-TRAN?
Yeah, fortunately, since we are not working with, a big distribution process, we're working with specific customers, we'll get good visibility in terms of what we need to be producing. So our inventory levels shouldn't be very high, because we're gonna obviously have to have a good prediction from, for example, the automakers to have our volume suppliers ramped up. It takes quite a while to make devices, so that lead time is going to be important in terms of them providing us some good projections. So our goal here is to really not keep a high level of inventory, because of the fact that we can have our device made at any traditional silicon fab because of the processes that we've been through.
And a follow-up, have your fabs seen special challenges with double-sided wafers?
Oh, like you wouldn't believe. We can tell you a whole lot of ways that don't work. It's really what a lot of the focus has been for the last couple of years, is to figure out, how do you process both sides of the wafer, since that's not commonly done? How do you protect one side while you're processing another? How do you avoid damaging it? Because the equipment that's out there is typically all geared towards single-sided processing. And it's really what's led to a lot of our IP, both in terms of the trade secrets and how we do it, and the patents around some of the processing techniques that we've developed.
Another question from Randy. What type of feedback are you hearing from potential customers about B-TRAN?
So far, it's been pretty exciting. There's a fair amount of education work that we need to do with the technical community, since it's a new architecture. And as they get through that understanding, the ability to actually get such a significantly higher level of performance without going to exotic materials got the technical community pretty excited. In fact, we gave a presentation at the Applied Power Electronics Conference last year, and it was selected as the best presentation. So we're seeing a great positive reception from the technical community.
That's great. Robert Biapol asks, what is the SimCool selling price, and how does it compare with competitors?
Yeah, so in terms of pricing, we keep that confidential because the pricing is dependent upon the customer and their potential volume opportunity. But typically, if you look at modules out there, they're typically $200-300 for an IGBT module that can perform, since it has multiple devices, perform as a bidirectional module. So that's kind of just the baseline, but in terms of specific pricing, yeah, we're not through distribution yet at this point, so it's really customer by customer.
Victor Robbins wants you to talk a little bit about sales, who your sales team is, how you're growing sales, marketing, and do you have a Super Bowl commercial this Sunday?
No, for us, that's not the best use of our capital. But we have a team that's working on business development, really focused on building those initial strategic relationships with customers that can drive volume. As we get through that next phase, we'll add a few more people to the front end of the business to actually start to broaden that customer base. And we already are working on some distribution channels in terms of how we want to take the products to market in some other parts of the world, like in Japan or elsewhere, where it's not necessarily cost effective for us to have direct salespeople over there at this point in the business.
Can you talk about the potential cost of goods sold? David Unger wants to know.
So, I mean, we're going to have a variety of products. Some will be multi-die, it could be single die. So it varies by product. But if you think about it overall, we're expecting roughly 50% gross margins on product sales. So it's going to be, 50% of the selling price of the unit. But again, in terms of pricing, that's something that will vary by product, and it's not something we can really disclose at this point.
Carrie Dukes wants you to talk a little bit about the plan for commercial production. Will it be contracted out?
Yes. Wafer fabrication is an incredibly capital-intensive business. And part of why we have focused so much of our development work on using that existing wafer fabrication infrastructure is so that we can go to large volume fabs and have them make the equipment for us, or make the devices for us. And it's part of what we're going through right now. We actually have 2 fabs that we are engaged with that are potential high volume fabs. They aren't the development type fabs that we have been using. They're fabs that have high levels of automation and can run high volumes of wafers for us. We'll complete the qualification of those fabs this year, so that as we move into commercial sales, we already have a high volume fab ready to produce devices for us. And the same with packaging. We're engaged with a couple of firms that actually can do high volume packaging of the devices, where they dice the wafers, package them up for electrical connection. And we've been through development work with them, so they are both ready to scale with us. So we've got all that lined up, ready to go as our commercial sales begin.
And last question, I'm going to combine one from David Unger and Walter Anasteo. Let's talk about the burn rate. What's your ramp to break even?
So yeah, as I had mentioned, we'll be just under $7 million here for 2022. As you look at 2023, it will likely be $8 to $9 million in terms of our overall cash burn. So that gives us a couple of years of cash. In terms of break even, it's still too early to predict. So we really need to see what the sales ramp looks like here in late 23 and into 2024 before we can project cash flow break even. But we do have a couple of years of cash really to commercialize the technology and really try to make significant progress towards that cash flow break even.
Great. Well, Dan, Tim, do you have any closing remarks for us?
We just appreciate everybody spending time to learn more about what we're doing in our story. We think we are coming out with a really innovative, highly competitive technology at the right time when we think about where we are with the deployment of electric vehicles and renewable energy. And we encourage everybody to follow our story and watch for our announcements against the milestones that we're going to be targeting this year.
Absolutely. Thank you so much for your time and this great presentation.
All right. Thank you for having us.
Thank you.
Okay, everyone, stay with us. We'll be back at the top of the hour with our next presenter. We'll be right back.